So now that we have talked about several theorems in Euclid, right? We've talked about those that are falling under the group for a center, those that are falling under the group cyclic quad, for the cyclic quad, and then those that are falling under tangents, right? Those that are falling under tangents. Now, remember that there are 9 in total, and truly speaking, it's just about application of those theorems. You just have to make sure that you do a lot of write-ups every day and try to identify the theorems in a diagram that is given. So today we're going to discuss the proof of the theorems that are examinable, the ones that are going to come up in your exam. So we're going to start with this one. We're going to start with the proof of a theorem that says angle at the center is twice the one at the circumference. So let's have our compass here and try to draw something. Okay, right. So here's our circle there. Sorry, let me just remove. Yeah. So here's our circle here. So I'm probably gonna copy this because we will need a couple of more of them. Let me just put it this side for now. Now there is a theorem here that says that if you have a circle right like this, and then you have a line that is going from the circumference to the center, as in this manner, and then you move from the same point, you go to the circumference. Now that theorem says that the angle formed here is gonna be twice the one formed at the circumference. So he says the one that is formed here is twice the one that is formed at the circumference. That's what the theorem says. Are we okay with this? So now that we have that, this is what we need then to prove. Okay, so they're going to tell you that suppose that you have here they have B, and then they have D here, and then maybe let's say C, and then there's O. Now they will say to you, prove the theorem which states that if O is a center, the angle subtended at the center is twice the one in circumference. So therefore they say prove the theorem which says that if O is a center, then BOC is gonna be twice angle A. This is what they want you to prove. Now the moment you get a question like this, you just have to ask yourself, which car in the world is the most luxurious and then the most beautiful, comparing between BMW and Mercedes-Benz. Which one would you say? Right, Mercedes. Yeah, that's a very correct answer. They say it's Mercedes-Benz. So now Mercedes-Benz, if you check its logo is something like this, the classic logo. Now why do you have to remember Mercedes? Is because the reason why I like this is because you can actually form triangles if you join the corners of that Mercedes logo like this. How many triangles do you form? How many do we form here? We form 4 triangles, right? This one, this one, this one, and the bigger one, isn't it? So you form 4 triangles. Yes. So now that so that's the beauty about having that logo. So similarly, you're gonna imitate that logo. You're gonna try and draw it here. How? Firstly, by joining B and C, right? And then by joining A and O, like this. By joining A and O. Right, if you do that, then it becomes 4 triangles. 1, 2, 3, 4, the bigger one. Okay, so this is something that you do when you are proving this theorem. We just remember that you must have 4 triangles, Mercedes-Benz. So you're gonna tell the examiner what you just did there. So you're gonna say construction. You're gonna say you can say join O and A, and then you say semicolon, join O and A, and then you say and B and C. Okay, B and C. You just explain to the examiner what you were doing there to draw that Mercedes-Benz logo there. Right, so after you have constructed that, the thing is that now you're going to have B1 and B2. This is something you must write on your diagram, because the diagram that I initially gave you, the one with this circle and the yellow the green thingy, the one we started with, that's the one you get in the exam. Then you construct number 1, and then number 2 you have to name your angles C1, C2, B1, B2, A1, and then A2. Now, just as a disclaimer, the proof that I use is not really taught in the class, right? Teachers don't really prefer this one, but then I find that this is the most easiest way of proving these theorems. So yeah, you might want to stick to this. So now, after doing that, let's understand the following. Before we even go here, I think I was supposed to start here, that if I have a triangle and then it's triangle KFC, if I'm given that KF is equal to KC, what can I conclude about these two angles? So we say angle F is equal to angle C. That's correct. What is the reason that we use? These are angles opposite equal sides. It's not something that is given. What is given is the sides, that they are equal. Then your conclusion is that the angles would be equal there. Right. So that's how we prove that. And then we get our angles to be that. And then another theorem, or rather another property of triangles that we need to remember. If I have that angle KFC, let's also remember that angle K plus angle F plus angle C, they will give me 180, and reason being that these are sum of angles in a triangle. Sum of angles in a triangle. So these two reasons are the most important reasons you're gonna need to solve these theorems. So now what you're gonna say there is that because we have constructed B, C, and that, let's understand that AO is gonna be equal to OB, is gonna be equal to OC. What could be the reason? What could be the reason there? Radi, ne? Those things are radiuses, because O is the center. So those things are radiuses. So we just write radi. So you must remember that after construction, you just clearly state that your radiuses are equal. It's quite important to state that. Why? Because that will mean now that this angle here is x, and this angle here is also x, because these are angles opposite equal sides. Similarly here, I'm gonna use y. I'm gonna use y for this one, and then y for this one, because they are also equal. And then lastly, I'm gonna use I'm gonna use X for this one. No, sorry, we have XY, right? Then I'm gonna use Z for this one. Then I'm gonna use Z for that. Those angles, all of them are gonna be, the pairs, they are gonna be equal. So this is what you're gonna write. You're gonna say to them, let, and then you say colon, let angle B2 be equal to angle C2, and let both of them be equal to X. Your reason being that these are angles that are opposite equal sides. Okay, that is the first thing. Second thing, let angle C1 be equal to angle A2, and both of them are gonna be equal to Y. Why? Because these are angles opposite equal sides. Which other ones? Angle A1 is gonna be equal, so this is Z there. My Z is kind of a bit ugly there, but let's try it. This is Z, Z, right? So we tell them that let A1 be equal to B1, and both of them should be Z. Reason being that they are angles opposite equal sides, because we already said that those radiuses are equal. So you'll understand that when you use this method, this is gonna be a standard procedure for all of them. For all of the theorems we're gonna prove, except one, we're gonna be doing the same thing. So once you've practiced this, you will no longer be thinking about it. It's something that you just be writing without thinking. Okay, that's the beauty of this way of proving. Now we are not done, because remember, the main goal is to prove this. So we are not done, but we are almost done. What are we then gonna do next? So what I will do here is that let me go this side so that I can finish it off this side. Now if you look, after writing this part, guys, after writing this part, because I said it's standard procedure, that part, meaning it's the same, it's common for all of them. The only different thing now is going to be the theorem itself. Now you're gonna go to here. Here's the theorem BOC. So now you're gonna make BOC the subject of the formula. How do we make, remember BOC is this one. We want to make it the subject of the formula. We want to get BOC in simple words. So how do we get BOC? Any idea? Is the third angle, are we gonna say B2 plus BOC plus C2? They must give us 180, right? When we add them, they must give us what? 180. And then our reason being sum of angles in a triangle. Now B2 is X, and then BOC we do not have, then C2 is X. Do we agree with this part? Are we together here? Okay, perfect. So now BOC plus the 2x is gonna be equal to 180 degrees, right? We are still together. Now if I want to make BOC the subject, I'm gonna say BOC is equal to 180 degrees minus 2x, right? Are we happy with this? In terms of how we got BOC, we are in agreement that BOC is 180 minus 2x, ne? It's fine, ne? All right, great. So if we're in agreement there, then we can definitely say, okay, we have BOC now. Now, guys, after getting BOC, you are done. You are just simply done. You know why I'm saying that? Because now you zoom out and you focus on the bigger triangle, ABC. And then you know what you're going to simply do there? You're just going to add all of the angles. If I add angle A, the whole of angle A, plus the whole of angle B, plus the whole of angle C, what should I get? Okay, angle A plus angle B plus angle C, I should get 180 degrees. Still, you are using sum of angles in a triangle. Now, angle A, if we check, it's Z plus Y. So you're going to write Z plus Y. And then angle B, it's Z plus X. So you're going to write Z plus X. And then angle C, it's X plus Y. You're going to write X plus Y equals to 180. Good people, what you realize there is that simply you're going to have 2x plus 2y plus 2z. When you are doing it now that you get used to it, you just know that if I add all of the angles there in the big triangle, I just get 2x, 2y, 2z. You won't waste any time. Okay. Right. So now, at the top, we have 180 minus 2x. And here is 2x here. Can we not take it to the left? We can, right? So, yeah, so we say, yes. So we say 2y plus 2z is equals to 180 minus 2x. Are we together in terms of how we did that? Oh, my apologies. Are we still together? It's 180 minus 2x, ne? Okay, perfect. So, wait a minute. If we were to take out a common factor here, do you agree that you're going to have 2 into y plus z? You agree with me? Okay. And then here we have 180 minus 2x. Now, guys, remember, 180 minus 2x, we said it was BOC. So I can write BOC. And then here I have 2 times. Guys, look at the diagram and tell me what is y plus z. Then you are done. Then we are done. We have proved that 2 angle A is equals to BOC. Yeah. It's not long if you are used to it. It's gonna be long if you are starting to see it and know it. But once you get used to it, you just see that this is a method whereby you don't have to think about what you are doing as much as the method of exterior angle what. Well, if you're comfortable with that, you can still use it. But yeah, you just see there what is happening. So this part is what we look for. So this part is a standard procedure. So I'm simply gonna say this one standard procedure, and it is always your step number 1. It's always your step number 1. Your step number 2 is simply to make BOC the subject. So that will be your step number 2, is to make the one in the question to be the subject. Remember, your step number 2 comes from there. You must understand. Your step number 2 comes from making BOC the subject. And then your step number 3 is the finishing move. So step number 3, that's your finishing move there. Because on step number 3, you're just adding triangles in. It's all angles in the bigger triangle. You are adding all angles in the bigger triangle. So you are simply adding angles in the bigger triangle there. And then yeah, you are done. So it's just adding angles in a bigger. So if you condense these steps, then that's when you see that it's quite short. Step one, common procedure. Step two, I just have to make BOC the subject using sum of angles in a triangle. Step number three, I must just add all angles in a triangle. I think even any grade 10 learner can add angles in a triangle. I believe any grade 10 learner can simply see that this is 2z plus 2y plus 2x. So that's something that shouldn't be difficult or something you need to crack your brain about. So then from there, you then prove that you just imitate though, right? Since you have 180 minus 2x, since you got 180 minus 2x, you just imitate the same thing, and therefore you find that your two angle A is BOC. Yeah, next theorem there. Let me just also take this one, for I might need it. Yeah, just take this one that side. Now if I wanna prove this here, you like a theorem here, right? There is a second theorem, but this theorem name, before you even do it, what happens if I have a circle and then I have a radius? Sorry, I have a tangent. If I have a tangent and then I have a radius, which theorem are you reminded of? Yeah, that's the theorem there, right? That's the theorem about tan perpendicular to red. Now, if you've memorized them in terms of numbers, that's also very much good. Yeah, it's fine. So you just have to remember that it's tan perpendicular to radius. Now, that theorem, we need to borrow it when we have to prove this one. So now the one we're gonna prove right now, which one is it? Yes, it's the tan chord. We're gonna prove the tan chord theorem. Now the tan chord theorem says if you have a tangent and then you have a chord from the point of tangency, right, then the angle between that tangent and the chord is equal to the angle subtended by the chord at the circumference. So what we're saying is that this one is gonna be equal to that. That's what the theorem says. So you are gonna get the diagram like this, and they'll just put O. This is what you are simply going to get in your exam, and then they will write here maybe let's still use maybe A, B, C, and then let's use G, C, E, right? G, C, E. Now they will say to you, now prove the theorem that says that BCE is equal to angle A. This is the theorem we must prove, that this angle here is equal to this angle there. So when you get this question, you don't have to think about how difficult it is or what. You just have to remember Mercedes-Benz. So you're just gonna join the corners here, and then you join the corners here, and then you join the corners here. Right, then you have your Mercedes-Benz logo. So because of that, now you're gonna have A1, A2, you're gonna have C1, C2, then you're gonna have this as C3, and then you're gonna have B1 and B2. Right. So from there, what do we then do? Remember that because you join them, this line is gonna be equal to that, it's gonna be equal to that. This is something we shouldn't forget, right? So our construction, you always start with construction. What did we construct? We joined, right? We joined O and A, and then we joined O and B, and then we joined O and C. Those are the three things that we joined there. So after doing that, we then tell them that OA is equal to OB is equal to OC, And remember, our reason is gonna be radi. OA is equals to OB is equals to OC. Our reason being that it's radi. So now that we have that, it's common procedure, guys. Now you know that you're gonna have X here, and then you're gonna have Y there. Then you're gonna have Z there. Then you're gonna have Z. Oh, by the way, the reason why these methods are not taught, indeed, they are perceived as being too much long. Indeed, they are perceived as being too much long. But I say a lot of students I've worked with, right? Like I'm telling you, once you practice these guys, you will see that it's quite short. So now that we have that, you know, you have to say let. So you let C2 be equal to B2, and both should be X. C2 should be equal to B2, and both should be X. Remember, angles opposite, equal sides. And then you're going to have B1 being equal to A1, and both are going to be Y, raising angles opposite, equal sides. And then you're gonna say C1 is equal to A2 is equal to Z. You still say angles opposite, equal sides. Right. Then from there, you are done with the standard procedure. You go to the question. The question wants BCE and angle A. So we have to make BCE the subject, which is this one. We have to make BCE the subject. But to make BCE the subject, it's outside. Remember, for the previous one, we made the other one to be the subject. We made BOC to be the subject by taking note that BOC was inside a triangle. So we use sum of angles in a triangle. But this one is outside the triangle. If you check, BCE is outside the triangle. Now, because it's outside, you are going to say, okay, since it's outside here, you're going to remember this theorem that since this is a radius here, and then this is a tangent, then you got a 90 degrees here. Do you agree with that? So this is something you're going to tell them. OCE is equal to 90 degrees. You're going to tell them tan perpendicular to radius. Right. Tan perpendicular to radius. But OCE is made up of X plus angle C3. Actually, let's write it as BCE. Right. It's that OCE is made up of X and BCE. But we need BCE to be the subject. So we say BCE is 90 degrees minus X. The moment we did this, right, or rather the moment we do this, then you're okay. You know the last step. Can you guess the last step? No, the 90 degrees is here, isn't it? Yeah, it's made up of two angles. Which angles are those? You get me? Right. So now, the last thing would then be to, like we did before, you add all angles in this triangle. So you tell them that you can write in triangle ABC. We can write in triangle ABC, angle A plus angle B plus angle C are going to give us 180. Sum of angles in a triangle. Now remember, I told you that when you add all angles in that triangle, it's simply going to be 2x plus 2y plus 2z plus 2z being equal to 180. Now you then check here. We have 90 minus x. So it means I should still take the 2x to the right, so that I'm left with 2y plus 2z being equal to 180 minus 2x. Right. But then But then there is a 90 degree here. It's not 180 minus x, it's 90 minus x. So what you can do now is to divide everything by 2. You divide everything by 2, and if you divide everything by 2, you'll be left with y plus z being equal to 90 degrees minus x. Now we do know that 90 degrees minus x is BCE. Now please look at the diagram and tell me what is y plus z. It's angle A. Then you have proved the theorem there. Because that's what we needed to prove. We needed to prove that BCE was equal to angle A. So, we are done then. Quite fast. quite fast. Yeah. So, like I told you guys, right? Standard procedure, right? Then I make BCE the subject, and then I just add all angles in a triangle. Then I'm done. Right. Then we can go to the next theorem. Now, the next theorem is about cyclic quads. And for cyclic quads, you need to prove two theorems, that the opposite angles of a cyclic quad are supplementary, and that the exterior angle of a cyclic quad no, the exterior angle, we don't prove it. Yeah, we don't prove the exterior angle. We prove that opposite angles of a cyclic quad are supplementary. So that's what we're gonna prove right now. So let me just take this that side, and then yeah. So you are gonna be given O here. They will give you a center shame. That one they will never make a mistake of not doing. If they didn't give you, you must ask for it. So now let's give you this, and then let's give you that, and then let's give you this, and then let's give you that. Then let's just call this A. Yeah. So let's call this A, B, C, and then D. Now we need to prove, right? We need to prove that angle A plus angle C is equal to 180 degrees. This is what we need to prove. Such a huge task, man. You need to prove angle A plus angle C is equal to 180. Okay. Right. Guys, you don't think too much hard. Just the Mercedes-Benz logo. If I draw the Mercedes-Benz logo, it means I just join the points to the center. I join the corners to the center, in fact. And then I'm going to join the corners to the center. But now it's not going to be a nice Mercedes logo. In fact, we just have to join even this one. You see? So now you're going to have, still, it's 4 triangles. 1, 2, 3, 4 triangles. Yeah. So you're going to do this. And by doing that, good people, let's remember that this line is going to be equal to that, it's going to be equal to that, it's going to be equal to that. The part of them being equal, please never forget. And then you're going to have B1, B2, C1, C2, D1, D2, and then A1, A2. Hey man, are we going to be able to prove this? Let's try. So we tell them construction. If you do not say construction, guys, you get 0 marks for the whole thing, even though it's correct. So you say join O and B, and then you say O and C, and then you say O and D, and then you say O and A. You say O and A. Right, then after doing that, you just tell them that they are equal. So OB is going to be equal to OC, is going to be equal to OA, is going to be equal to OD. Reason being, they are all radiuses. Because O is the center, they will give you the center. Now, after that, you say let. So you're going to say let. Now, you have to have X, Y, and Z. So I'll start here. Let's call this X. Let's use a different color there. Let's call this x. Let's call this y. Let's call this z. And then this one, let's call it w. So you have x, y, z, w. So you're gonna say let c1, okay, maybe let's start here. Let d1 be equal to c2, and both of them, let them be x, due to them being angles opposite equal sides. And then let angle c1 be equal to angle b2, and both of them should be y, because these are angles opposite equal sides. Let what? Let b1 be equal to a1, both of them should be z, angles opposite equal sides. And then lastly, let a2 be equal to d2, be equal to w, angles opposite equal sides. So now that we have this, right, we just now have to prove that angle A plus angle C is 180. Now guys, a triangle, when you add the angles in a triangle, you get 180 degrees. But what happens when you add angles in a quadrilateral? What is the answer that you get? You're saying angles in a quadrilateral, they add up to 180. Yeah, it's 360. A square has 90 degree, 90 degree, 90 degree, 90 degree. When I add those 490 degrees, it doesn't give me 180, but it gives me 360. So sum of angles in a quadrilateral is 360. So that's what you're simply gonna do here. This one I like it because you skip the step of making this one the subject or that one the subject. Nah, you don't have to do that. You simply go straight to adding B, C, D, and A. So you just tell them angle A plus angle B plus angle C plus angle D. When you add them, what should you get? 360 degrees. Why? Because these are sum of angles in a quad. Sum of angles in a quadrilateral. So you say in a quad. Right. So now let's check what is angle A. Angle A is Z plus W. This one is B is Z and Y. Guys, you don't have to stress. This is simply going to be 2x plus 2y plus 2z plus now 2w, because there is W. You can check it for yourself. So now that we have this, let's check. We need to prove that they equal 180, not 360. So what are we going to do to reduce the 360 to 180? Divide everything by 2. Same way we reduced 180 to 90 degrees the other time. So if you do that, you will have x plus y plus z plus w being equal to 180. What if I tell you that you are done? You are done there. But how? Wait. Look at angle A. Angle A is what? Isn't it Z plus W? Angle C, isn't it X plus Y? So you simply say, therefore, angle A plus angle C is 180 degrees. Yeah. So even if they wanted you to prove B and D, you wouldn't stress. This also proves B and D. Do you know why? Because check. I'm just going to rearrange them. Check. Z plus Y is this one. And then X plus W is these two. So they also prove that B and D they equal to 180. So when it's just about rearranging the letters to the one that you want to prove, and then you are done. Are we clear here? Right, so yeah, that is how you prove that theorem, man. Then we are done with the hard theorems. That's it. The long theorems, as they say. Yeah, we are done with them. That's simply how we prove these. And you can just practice them, and you always get your answers correct there. Remember, this could be 6 marks, 5 marks. They're always from 5 to 6. So you already have 5 marks or 6 marks guaranteed into your exam. For sure, for sure. Yeah, that's where we are going to say. Like I said, we'll prove 4 theorems. And get, you are right. We prove also theorem 1. Now, this is, like I said, we are done with the difficult theorem. That's what I was saying. We are done with the ones that maybe take time. Then we go to the easy one. So they will give you this line, and then they'll give you that line. Upon telling you that this is O, which is the center. Yeah, and then you have A, B, C. So now you need to prove that AB is equal to BC. You are proving the theorem that says if you have a line from center perpendicular to chord, it bisects the chord. You are trying to prove that indeed is true. Now, I remember my grade 11s. They're like, I say, but it's not Mercedes. Okay, it's fine. It's not Mercedes. It's just a cut Mercedes. What do we mean? You're just gonna join A and O. Now that you are in the mood of joining, then you will never forget that I must join here. So you join A and O, join O and C. So you're gonna tell them there that a construction. You don't forget construction. You tell them O is equal to A. No, join O and A, and then join O and C. Then you tell them OA is equals to OC, Radi, and then from there, yeah, people when they solve this, they do it through congruency, right? Yeah, I'm just not a fan of congruency. So what I'll do is that I'll put B1 here, then I'll put B2. So I'll tell them that angle B2 plus angle B1, when we add them, what should we get? Should be 180, ne? Right, angles on a straight, perfect. So therefore, because of this, since B1 is given as 90 degrees, then it means B2 should also be 90 degrees. Okay, perfect. So now we know that this is also 90 degrees. Now I have 2 right angle triangles. So for me, when I see 2 right angle triangles, I'm reminded of Pythagoras theorem. So let's not forget that OA is equals to OC. This is very important, just that I didn't indicate. It must indicate. So OA squared, can we agree that it's OB? Oh my goodness, what's wrong now? It's OB squared plus AB squared. Do we agree with this? That is the Pythagoras theorem. Okay, perfect. And then OC squared, do we agree that is OB squared plus BC squared? Still a Pythagoras theorem, ne? Right. Now, but remember, we already said that OA and OC, they were equal. We already said that, Radi. And OB and OB is just the same thing. It's a common thing. OB and OB is the same thing. So if this part and that are the same, and this part and that are the same, then that should mean these parts are also what? the same. So yes, you tell them but, right? Remember, this is therefore, ne? But then but you use this one. You say but OA is equal to OC, and then we already proved it. And then OB is common, and OB is common. So therefore, because of that, you tell them that therefore AB squared will be equal to BC squared. Now if we say root, you say therefore AB is equal to BC. Then you are done. So you're going to be using the Pythagoras theorem to prove these things. But then if you don't like the Pythagoras theorem, once you reach this point, you can use congruency to prove that. So how you use congruency is the following. You tell them that okay, we already said OA was equal to OC. You tell them that OB is common, right? And then you tell them that angle B1 is equal to B2 because both of them are 90 degrees. So you say therefore triangle AOB is going to be congruent to triangle OBC, and the reason you use there is what? It's a side, it's the right hand side. Sorry, not right hand side. Right angle, hypotenuse, and a common side. The hypotenuse are equal since OC and OA are equal. There is a side that is equal, which is the OB that is common. Then there is a right angle, which is B1 and B2, which are equal. So that proves congruency. And therefore, from congruency, you simply say AB should be equal to BC. You don't have to give a reason. You just leave it like that. Because the triangles are congruent, which means they're equal in all respects. So it's going to mean that this and that are equal. So yeah, you might then see that if you're using Pythagoras, you're kind of taking the longer route. If you're using congruency, you are taking the shorter route. So it just depends on you. But then this is what you should write. It's common procedure there. You must make sure that you include it there. Alright. Then we have proved that. Good people, is there any question? Is there any way we didn't understand in terms of proving the theorems? Exactly same. You are allowed to use them. Alright, so that is how you do them, and that's how you can prove those theorems, right? Let's just practice these theorems, right? Make sure that you practice them. When you check previous papers there, they're gonna have them. I always say to people, do one per day. At least prove one theorem per day, right? These theorems are not difficult to draw because you simply do this. You simply say this, and then this, that, and then this, that. Then when yourself, you can give yourself letters and start proving that this angle is 2x and that is x, or rather this is twice that, you see. And then the other one is tan chord. Just draw a tangent there and draw a chord, alright? But make sure that you have a center here. Then start proving that this and that are equal, at least per day. And then the other one is cyclic quad. Just draw the cyclic quad there, right? And have a center and start proving that this, when you add it to this, you get 180 degrees, right? Prove that theorem there. And then just draw a line, just draw a chord, draw a perpendicular line from the center, and you just prove that this one there is going to be equal to that. These are the four main theorems. Recently, I've heard that they are also now asking about the inverse, the converse of theorem 1. So that one I'll leave you for you to just go ask in class there if maybe it's assessed or not. But then I've given you the core ones that you must know, and then definitely you can know them by heart, because if you make x, y, and z here, you know that I just have to make this one the subject, and then I add all angles in a triangle. And then if I make x, y, z here, I just have to make this one the subject by using tan perpendicular to radius, and then I add all the angles in a triangle. Then this one I just make x, y, z, and w. When I add all of them, I get 360. Then I've proved that these things are supplementary. And in this, you can use congruency, or you can use Pythagoras theorem. Thank you so much.